Good afternoon. This is Matthew Mary, Director of Emergency Preparedness with the Virginia Hospital and Healthcare Association. Thank you for joining us for the National Weather Service briefing on the 2022 hurricane season, today, June 1st, 2022, as today kicks off this year's hurricane season. A few housekeeping items. All lines will remain muted throughout the duration of today's webinar. If you have any questions for the panelists, please type them in the chat box. If time allows, we'll host a brief Q&A session following today's presentation. Slides are located in the handout section for your reference. The recording of today's webinar will be emailed out to all registrants this afternoon. On behalf of the Virginia Hospital and Healthcare Association, I'd like to introduce our colleague, James Moss, State Hospital Coordinator at the Virginia Department of Health, to say a few words. James?
Thank you, Matthew, and welcome everyone. I appreciate your attendance on this timely webinar. On behalf of the Virginia Department of Health and the Office of Emergency Preparedness, we welcome you. And thank you for your participation in this very timely webinar and the partnership we have with the National Weather Service. I'd like to introduce Mr. Eric Seymour. He is the Warning Coordination Meteorologist with the National Weather Service Wakefield office. He and his colleagues are no stranger to emergency management within the Commonwealth and have been a great partner over the years in assisting VDH, VHEMP, and our other state agencies in our localities in preparing for hurricanes and other weather disasters. I think this is a great opportunity to broaden the kind of awareness in regards to hurricane season as we are on the first day of hurricane season, and to provide you some context and some information that you may not have previously been aware of. So it's my pleasure to introduce Eric, and Eric, please feel free to take it away.
All right, thanks, James. Thanks, Matt. I appreciate you guys inviting me in to share with everybody today. As James said, today is the first day of hurricane season, so we're going to take a look, take a look back. Here we go. Looks like it muted me again. All right, so what I was saying is we're going to take a look at the 2021 season. Take a look back. It was a pretty active year in the Atlantic Basin, and the state of Virginia had a few systems move through. We're going to go from there. We'll take a look at the hurricane climatology. What is normal? What can I normally expect to see? When can I expect to see it? And then we'll take a look at the ingredients. We'll take a look at some of the Hurricane Center products that our office uses that are available for people to use to kind of make decisions upon things of that nature. And then from there, we're going to head in and look at the 2022 forecast at the very end, just so we can kind of see what direction we're headed. Okay, so this was the map from last year. This was all the storm tracks in 2021. Overall, we ended up with 21 storms, and you see a vast majority of them were out in the Atlantic, didn't really impact the U.S. However, we did have 8 storms that did impact the United States during the 2021 season. So here's kind of a picture of all of the different storms. So you went from Ana all the way down through Wanda. That was the full complete list. The list has 21 names in it, and we used them all. If you remember back in 2020, we used all of them plus some as we went into the Greek alphabet. And if for some reason this year we go beyond 21, there's actually a alternate list now of names that go all the way back to the letter A, and we begin again, as opposed to using the Greek alphabet, since some of those storms with the Greek alphabet were fairly memorable. So that's been one of the changes that was made last year. So if we do get through all the list of the names this year, we'll get into that supplemental list. Hopefully we don't get to that point in the season. But again, we've had 6 consecutive years where activity's been above normal. And when we get to the forecast, I think you'll see that we may be headed for a 7th. All right, so looking back, there were 8 U.S. landfall. 6 of them were tropical storms, 2 were hurricanes. Ida obviously drew the vast majority of the name recognition and interest last year. But a lot of the other storms that went through did cause some issues and had some impacts. But again, vast majority of things came from Ida. You can see the direct fatalities, 56 from Ida, and a lot of that is from storm surge, storm and flooding, those kind of things. Those tend to be the dominant factor, and we'll look at that as well. You see $75 billion in damage, more than the entire 2020 season. So again, you had quite a bit, and a lot of it came, Ida produced just a vast majority of the impacts last year. So we're going to take a look at, there were 3 storms that actually impacted parts of the Commonwealth. Elsa, Fred, and then Ida being the last one. Elsa probably had the largest impact on the Commonwealth, anywhere from 1 to 5 inches of rain, and really it split kind of up along the I-85 corridor, headed up into the northern neck, was kind of the main axis. We did have some pretty significant winds with it as well. You can see some gusts well up into the 40 to even a few gusts up into the upper 50s to around 60 miles an hour. And again, it was mainly in the coastal areas. But that was kind of with the system as it came through. The other impact was we did have 5 tornadoes. So, and those were in the in our county warning area, which you see, which is pictured here. So we actually have a few counties in North Carolina and Maryland as well. So of those 5 tornadoes, 3 were in Southeast Virginia. They were actually in the Smithfield, Suffolk area, all 3 of them. So generally speaking, they were EF zeros. They had winds around 60 to 65 miles an hour. And for the most part, the damage was kind of limited to some trees, maybe a few things being tossed around, not a lot of structural type damage, but definitely was still there. And that is one of the impacts that we see from these systems. Tropical Storm Fred, this occurred later in August. It had 2 to 5 inches of rain, and this was out in the western part of the state as the system was coming up through the Appalachians, produced heavy rainfall in the Carolinas, not quite as much as we headed up into Virginia. But the one thing that this did was it did set the stage for more significant flooding as we got later into August. I know we had the flooding that was in Dickinson and Buchanan County late in August drew a lot of attention, and this was kind of the primer for it. This kind of got things started by starting to pump up the rain totals. So while Fred's impact wasn't immediate, it was still felt. It wasn't, it was several weeks later before we really kind of saw the impacts that were caused because, Fred had kind of gotten things wet and saturated the ground. Ida came in right at the back end of August into early September. Obviously, the big impacts were along the Gulf Coast down toward New Orleans. And but then once you came up toward New York City, you can see where it, things increased again. The rainfall totals really jumped up. We had a lot of significant flooding. We had tornadic activity, things of that nature. But what you can see here from the rainfall is, we did have some pretty significant rainfall, kind of 1 to 4 inches, and mainly, kind of the I-81 corridor in areas to the west is where we saw that rainfall. So again, it caused some, there were some minor flooding issues and things like that occurred from that kind of rainfall. And actually in Montgomery County, which would have been just on the south side of the track, there were 2 confirmed tornadoes. So, even though the Commonwealth doesn't necessarily always have, most of the time we're not seeing a direct landfall into the state is still impacted by tropical systems every year. So this was the 3 from last year that impacted the area. All right, so that was just a zoomed in shot. All right, now we're going to take a look at hurricane climatology. This was actually a satellite image from the 2020 season. And the reason I like this one is we actually can see 4 different systems in the Atlantic Basin at one time. So, satellite gives us a lot of good information, and it really kind of helps us kind of, find the target areas. And that's what we're going to talk about in the climatology. Where are the target areas? Where are these things expected to form based upon the time of the year? And satellite's one of those big tools to help us do that. So here's all the different tracks, and this goes back from 1850 to present. So we're talking, 170 years worth of tracks. And notice it looks very complicated, convoluted, things of that nature. There's tracks going all over the place. The one thing I want you to kind of focus in on, notice a vast majority of the tracks go from southwest to northeast. That's where most of our tracks go. And the ones that are along the coast, when they're going southwest to northeast, typically we're on the western side, which usually means we're on a little bit of the weaker side of the system. So it does tend to limit some of the impacts being on that side. Doesn't mean we don't have them. It's just they may not be quite as bad as if they were making landfall. The ones that we do have to watch more for dramatically than anything else are the ones that are moving from the southeast to the northwest. Isabel coming to mind, the 1933 storm coming to mind. Okay, that type of a track. Even Fran in 1996 caused a lot of damage because the winds held together well inland. And it's that track moving southeast to northwest that really gives us a lot of problems from a wind perspective and things of that nature. So, keep that in mind. Most of these ones that are moving, especially the ones that make landfall across the Gulf, still causes problems, but it's usually typically, a rain scenario where we're seeing a lot of heavy rainfall and things of that nature. So just because it doesn't make landfall here doesn't mean it can't be a problem. It's just that the ones, especially that are moving in that, southeast and northwest, really tend to have a lot more. The wind seems to hold together more, and we tend to have more issues, especially with surge and things like that, because we're pushing water to the coast the entire time period. So you can see when it comes to hurricane tracks, the hurricane tracks are much less. They're most of them are closer to the coast. I'm really not seeing any hurricane conditions once we get further inland. Most of the systems that affect more of the western part of the state are coming from the Gulf, and usually from a wind perspective, they've weakened by that point in time. Okay, hurricane return periods. This just gives you an idea of, from a climatological perspective, how often should I expect to see hurricane force winds, making landfall or in the state. And so you can see the coastal counties marked in gray. Typically speaking, the return period for hurricane force winds in Virginia is anywhere from 13 to 15 years. Irene was the last time we saw those type of actual hurricane force winds in the state. That was 2011. So if I do a little math, it's 2022. It's been 11 years. From a climatological standpoint, we're not that far away from hitting when we should, based upon what we've seen in history, when we should see something making landfall. So as we start moving through not only this year, but the next couple of years, you have to kind of think that at some point in time, we're going to see an actual system with hurricane force winds hitting the coastline. So could it be this year? It might, but it may not be. Just something to kind of keep in mind that, from a historical standpoint, we're getting back to where we should potentially see, one of these systems making landfall. All right, now if we're talking about hurricane generation, there are different places in the Atlantic Basin we look for hurricanes. So this time of the year, I'm not looking in the central Atlantic usually. Usually the wind structure of the atmosphere is not going to be conducive for supporting development out there. Sea surface temperatures are marginal still this time of the year out there. So, it takes a little while for those conditions to warm up. This time of the year, in June, we're looking in the Gulf of Mexico. The water temperatures down there are already in the mid to upper 80s, which is well warm enough to support tropical conditions. And the wind conditions are such that usually systems are able to develop down in that part of the country. We've also seen it off the East Coast. The last couple of years, we've had actually systems in May off the East Coast. Typically, it's along a stalled frontal boundary or something like that sits there for a while, and eventually a storm's able to form on it. So that's kind of the general region that we're looking at in the month of June. Now, as we move into July, we're still kind of looking in those same areas, but we do start to gradually look further to the west, getting out toward the Leeward and Windward Islands in the Eastern Caribbean. That tends to be an area that starts to become more active. Sometimes we can get convection developing into tropical systems, in the central Atlantic, but that's typically not the main location. Usually it's more still Caribbean and then in the Gulf of Mexico. But watch as we expand here in August and September. Look at the areas that suddenly become, generation locations. It's pretty much almost the entire Atlantic Basin. You can start to see development occur. The Eastern and Central Caribbean become much more active. And even as we start getting all the way back to the Cape Verde storms for the waves coming off of Africa, August and September, That's the peak of the hurricane season. We'll look at a graphic here in a minute that kind of shows that, but that's really your generation area. The wind fields become much more conducive across the entire basin. The waters are significantly warm, and it's the time of the year when we do expect development to occur. Now, as you start to head into October and November, we start to see the Atlantic itself starts to cut off. The wind patterns change. We're getting into the other side of the fall equinox, so we're getting now into the point where we have less sunlight than darkness, things of that nature going. So things start to change. The wind patterns start to change. So in October, things move back toward the coast. You notice we're getting back into the Caribbean being a hot spot, maybe off the southeast U.S. coast, and then gradually as moving in November, really most of the activity does tend to weaken. That doesn't mean we don't have any. Several years ago, Hurricane Lenny was a Category 4 storm in November that moved, and it actually moved west to east and impacted parts of the Caribbean. So you can still get stronger storms, just because they go to November, but it's just the areas where generation occurs really start to become less and less as we get to November. All right, so when do we see the most hurricanes? We get to the second half of August, things really start to ramp up. We peak mid-September, usually around the 10th is considered the kind of the midway point of the season. Then things start to diminish a little bit. We actually get another little, for some reason, somewhere in mid-October, we like to see a little bit of a bump in activity. If you think back several years ago, 2018, Hurricane Michael was in that period of that bump where we see that little increase in the number of storms. So, that still tends to be kind of the, I like to call it the last hurrah of the hurricane season before things really start to wind down, diminish. So, really we're looking at about a 2-month period, between mid-August and mid-October is where we expect to see the most number of storms. But you can see based upon, we can get them anywhere starting in June, and they can linger all the way out even into early December. All right, so let's take a look at the ingredients that we're looking at for these tropical systems, because that's important to know why they form and why they're different than the other storms that we get. First thing is they need the warm ocean water. They need warm ocean water to help fuel the thunderstorm. So the energy that's contained in that water with the 80-degree temperatures or above really helps to fuel the thunderstorms and provides the energy to it. And for these storms to grow, we need thunderstorms. We need a lot of thunderstorm activity. And the other thing we need is we need to be able to get an area of low pressure to form. So you've got to get the air swirling in, things of that nature. If you're too close to the equator, and one reason we don't see these below about 5 degrees north latitude is once you get down by the equator, you kind of lose the ability to get rotation, to get the clockwise spin, and that's called the Coriolis effect. Okay, so without being able to get the counterclockwise spin, we can't get an area of low pressure to form, and the system's not going to develop. So generally, we're looking north of that 5-degree latitude line on the satellite imagery. And the last thing we need is light winds. And why do we need light winds? Because typically when we think of tropical systems, we think of strong winds. Well, we're thinking of strong winds at the surface, but at the higher levels of the atmosphere, we want light winds because we want to allow the thunderstorms to be able to grow and develop vertically. So if you think about analogy I like to use is, when you've got tall grass growing in your yard, if you want to get it back under control, you cut it. So you cut the tops off, and that tends to slow things down, get your yard back in shape. Well, when you're dealing with tropical systems, if you want the system to weaken and kind of get back to a more normal state where we're not having a stronger storm, cut the tops of the thunderstorms off. You cut the tops of the thunderstorms off, the storm is going to weaken. It's not going to continue to grow and develop. If we allow the thunderstorms to continue to grow and stay very tall, okay, then the storm is able to continue to grow. Air continues to flow in at the surface. It continues to flow in at a faster rate because, as you can see, as air is forced upward with the thunderstorm activity, it's pulling more air in at the surface. It allows that area of low pressure to form and develop, and the winds get stronger. So, easy way to weaken the system is cut the thunderstorms off because you're messing up just this entire wind flow pattern that occurs. And the winds tend to weaken. If the air's not flowing in at the surface, the storm's going to end up being weakening. So that gives you an idea kind of schematically of what we're looking at when we're dealing with these storms. All right, so let's take a look at the different hazards here. Okay, and we like to use the acronym of SWIFT because when we're dealing with there's basically 4 main hazards we're dealing with hurricanes. We're dealing with storm surge, we're dealing with wind, inland flooding, and inland flooding in a lot of cases doesn't get quite as much publicity as it should. and then the last one being tornadoes. If you live near the coast, there's one more in there that we look at, and it's waves and rip currents. So there can be a lot of beach erosion, things of that nature. Storm surge can be an issue there, but it can be an issue inland as well. So we're going to take a look at all those things. When we're looking at wind, that's what most people think about, because when you tune in to see, hey, what's the storm doing? How strong is it now? When people ask that question, the first thing they go to is, hey, it's got 120 mile-an-hour winds now. So the wind is the thing that usually people think about, and and it does a lot of damage, as you can see from the images here, whether it be structural, whether it be tree damage. There's just a lot of stuff that gets blown around during these storms. When we talk about putting the storms, we tend to put them in categories. We put them in hurricanes. It's a Cat 1, it's a Cat 2, maybe it's a Cat 4 now, and it's all based upon what the sustained winds are. And this is called the Saffir-Simpson wind scale. Now, it used to be that the Saffir-Simpson scale included surge too. You'd have a Category 1 storm had not only what the suspected winds would be, but also what the surge would be. But now we've figured out that surge doesn't follow that same game plan as well. So we pulled surge out, and surge is its own entity now. And we'll talk about storm surge here in a few minutes. But what you can see on the chart here, based upon the different category, it gives you an idea of what type of damage you could be occurring, based upon what the impacts would be, whether what kind of homes, buildings are going to be damaged, those different kind of things. So I'm going to pull up a Category 3 and zoom in here a little bit. Once you look at Category 3, we're talking winds of 111 to 129 miles an hour. You're talking about devastating damage. Well-built frame homes may incur major damage, removal of the roof, gables. Most of your trees are going to be snapped and uprooted. And you got to be, if that's the case, you got to be thinking from an electricity and a water standpoint. It could be several days to weeks after a storm passes. I know in hurricane, when Irene went through here, Irene was a Category 1, and there were several folks in my office here who lived varying locations around the area, who they were without power for a week, and that was with a Cat 1 storm. So just think about if we had a Category 3 make landfall, what that could be. The other thing I want you to take a look at is in the chart here, and you can see the chart that's kind of on the right-hand side with the category, the wind speed. But I want you to look at the last column. It says the damage potential multiplier. This is not, as winds go up, it's not a linear increase in that multiplier. Okay, it's exponential. So if you look at in a Category 3 storm with 115 mile-an-hour winds, the damage multiplier would be 30 times greater than what we would expect with a Cat 1. Okay, if it's just 10 mile-an-hour greater from 115 to 125, that jumps from 30 to 60 times greater. So we're doubling that multiplier just with a 10 mile-per-hour increase in wind. So, as the winds really start to ramp up, a 5-10 mile-an-hour change can really be dramatic as far as what the damage goes to. So, keep that in mind. As we're looking at these storms and things like that, if we start looking at it, a system maybe getting to, maybe it's a Cat 2 and it's got winds, let's say, 110 miles an hour, that's much more significant than a Category 1 storm with 95. It's only a 15 mile-an-hour difference, but the amount of damage could be dramatically different between the two. All right, water. Water is one of these other elements we think of, and water kind of covers in two things. It covers storm surge, but it also covers your rainfall and your inland flood threat. And sometimes you can get a combination of both. But the thing that people really need to remember about water, with everything we talk about, wind gets all the publicity, but water is what kills. From all the studies that we've looked at, okay, the vast majority of people who die in hurricanes are dying because of being involved with water somehow, whether being captured in storm surge, being caught in rainfall and flooding rainfall. And then a couple of the other ones you can see, they're small, but, people get out in the surf. People still like to think that they can go out in this stuff, along the coast, things like that. Not a good idea. Between the dangerous waves, rip currents, all those different kind of things. There's a lot of problems if you try to be out in the surf in this. And then people offshore, occasionally we do have somebody who's in a boat or something that goes down in these things. So, that's where, 89% of the deaths have occurred are attributable to water. So that's why we kind of round it up to say 9 out of 10 people, because that's kind of, you know, where we are. People need to be thinking about that, that it's not just a wind issue with these things. You know, wind is a visible issue as far as seeing the damage, but the water in a lot of cases really is what causes the fatalities to go up. All right, so we're talking about storm surge, okay? What are we actually talking about? Because the tide goes in and out every day. So water comes in, water goes out. But what we're looking at here is the area above that normal tide, okay? So generally speaking, along our coastline, you know, our tidal range from low tide to high tide, somewhere usually between 2 and 4 feet at most of the gauge locations, whether you're on the bay, whether you're on the ocean side. That typically is what the range of levels is. So, you know, if we have our normal high tide, we're about 2 feet above what will be a normal level, you know, but typically that's not flooding. You know, typically that's just the normal, where the normal water goes. What we're looking at is this in storm surges, we're looking at this extra water. We're looking at this extra amount of water that is on top of the normal tide. And the other thing is it can also have waves to it. So not only are we looking at the 15-foot surge, but we also have to think about the wave action that's on the top. So if you've got waves on top of that water that are being driven by the wind, that wave action battering on buildings and things like that and structures is eventually going to cause them to weaken and fail. And that's typically what we see along the coast. And if anybody's seen images of the last couple of years down across Louisiana, you know, or maybe down toward Galveston with Harvey in 2017, you know, you'll see the picture of the landmass before the storm and then after the storm. And it's not the winds bringing those structures down. It's the storm surge coming in and the waves battering on those buildings to knock them down. So, you know, water's got a lot of power like that. You know, so that's just, you know, again, this is a coastal phenomenon, but it can reach back up into the area rivers, whether it be into the James, the Rappahannock, you know, down the Elizabeth River, you know, any of the areas along the bay, you can see that surge push inland, well inland, and we've seen it even as far as Richmond, because the tidal signature makes it all the way into downtown Richmond. We've seen that water being pushed all the way up. So it can get there. Obviously, you're not going to have the wave action on top that you have at the coast, but it can push a lot of water. So we can see that flood threat from the surge extend well inland. All right, so when we're talking about inundation, because when we're talking about storm surge flooding, you know, I can tell you when we may have 5 feet of storm surge coming in, but for most folks, that really doesn't mean a whole lot. They're trying to relate that, very difficult. So what we're actually looking at is what we want to talk about is what is inundation. Okay, we're talking about where water's going to get to from a location that is normally dry, and that's what inundation is. So when we're doing, you're seeing these storm surge forecasts come out, a lot of times what you're going to see is we're going to be referencing how many feet above ground level to expect the water. So in this case here, you can see the bottom image, the normal high tide. The beach chairs are good. Where that black dot is, hey, that area is normally dry. Well, when we get one of these storm surges, then suddenly that area is now wet. So we're going to be denoting what the water level would be at that location to give you some idea, so you know kind of what to expect, how deep it is, things like that. So that's what we're talking about when we're talking about inundation. We're talking about areas that are normally dry, having water from the ocean coming inland, pushing in and covering that land and making it wet. With coastal flooding being such a big factor, not only during hurricane season, but the rest of the year as well. We deal with it in the fall with the king tides. We deal with it in the wintertime with the nor'easters. We had a nor'easter this year in early May that caused a lot of flooding. So, you know, our office, you know, does coastal flooding forecast all year long. Okay, so it's not something that we only do during tropical season. We do it all year long. So it's just another tool for folks to use. And this is based upon the gauge. Most of these gauges we have established flood values at, which we know what minor, moderate, and major would be. And so based upon those levels, localities can then come in. They're going to have plans made up. They know based upon if we're forecasting minor flood at a location, they're going to know what areas in their you know, their jurisdictions typically flood to start making impactful decisions as well. So you'll be able to use not only our forecast, but also what we're getting from the Hurricane Center as far as that in that decision-making process to know kind of what you should be planning for. All right, dangerous rainfall. We know we can get a lot of rainfall from these systems. We saw it a lot in 2020. You know, I know we had it with Zeta produced a lot of rainfall across the Commonwealth. Isaias produced a lot of rainfall. Looking back at a couple historic storms for Eastern Virginia, we were looking at Hurricane Irene and Hurricane Floyd. Floyd produced tremendous rainfall, okay, well over 10 inches of rainfall in a wide swath. Irene produced similar amounts, but not quite as much, even though the tracks are very nearly the same. So when you start looking at rainfall, one of the things you really have to consider is the speed of movement with the system. Track's important, but that speed of movement is really important as well, because the slower the system moves, the more opportunity there is for rainfall, the more time there is for rain to occur. Florence down in North Carolina in 2018, very slow mover, came inland, took 3 or 4 days before it finally cleared the state and moved to the north. On that time period, it dropped 20 to 30 inches of rain. So we know if the storm's coming in and not moving, the rainfall totals are going to go up. And as the rainfall totals go up, the flooding rain threat just gets dramatically, increased. So, if we get one of these systems coming in and it's moving in that, southwest and northeast direction, which is kind of what you're even seeing here on these tracks, as long as the system's moving pretty quick, usually we can get through without the rain being too bad and causing too many problems. But if it slows down, sometimes, the rainfall rates can get very dramatic. And then we have a lot of flooding issues because a lot of our areas, we've got a lot of rivers across the state, things like that. A lot of cases, especially in the west with the terrain, you get this kind of rain with terrain. You're going to have flash flooding threats there. Rivers are going to swell quickly. So there's a lot of impacts that can occur based upon the amount of rainfall. So again, the speed of movement and the track's important. And sometimes, even before the system makes landfall, we can see heavy rain. So sometimes we see it's what we call it in the meteorological world, we call it a pre. And it's just kind of a pre-event rainfall, but we can see some very heavy amounts with that. Thinking back, Hurricane Matthew in 2016, we saw that type of a pre-setup across from the I-85 corridor, going all the way up into Richmond, where we saw a large band of 4 to 6 inches of rainfall well in advance of Matthew. Matthew ended up curling off the coast and produced heavy rain down for Suffolk and those areas, but there was a band much further inland, and there was one of those pre's that was set up. It's initial rainfall that just sets up. Sometimes it's interaction with a frontal boundary that may be stalled or something like that, and when you're throwing tropical moisture up along that front, you get enhanced rainfall. So we can even well in advance of these systems, we can see heavy rainfall. All right, tornadoes and water spouts. Those are definitely things you can see with these systems. They tend to be in the right front quadrant of a system making landfall. So in this case here, this would be an example. You had a system, and to be honest, be very reminiscent of what we saw in Isaias. You got the system making landfall. So in that right front quadrant, the system's moving to the north. That's where you're most likely to see it. In a lot of cases, you're going to see it in the outer bands. They tend not to necessarily be kind of like real close to the circulation. They tend to be more in these outer bands, and it's these bands that as they move from off the water onto land, they're encountering some friction, things like that, as it moves over land that really helps them spin up. The other thing that we've seen is if we get some drier air to the west, it starts to entrain into the system. That seems to be another thing that helps them trigger. But again, not every one of these systems produces tornadoes. Fran in 1996, Isabel 2003 produced a lot of wind damage, but didn't have very much in the way of tornadic damage. When we look at Isaias in 2020, you had a system that made landfall as a Category 1 hurricane, was a tropical storm moving through Virginia. It produced 15 tornadoes in our forecast area from North Carolina up through Maryland. So again, some of these systems can be very prolific at generating them, and others not so much. So, but you have to prepare that this is one possibility you could see when you're dealing with these tropical systems. Okay, we're going to kind of hop by the rip currents. Again, this is something you'd be along the beach. If we've got one of these making landfall, we don't need to be out at the beach. We need to be somewhere and protected. Okay, so products you should know about for the 2020 season, and this is really important. The cone graphic, this is going to be the first graphic that everybody sees during the year. When you go look for a product, this is one that gets shown a lot because it's showing the track, it's showing the warnings, and you can even see the kind of what the projected current wind field is of the system. But what I can't tell from this graphic is what the impacts are. Okay, so that's one thing to remember. I can't tell what impacts maybe from air. Only thing I can tell is the track. The other thing to keep in mind is, okay, when we start talking about the cone, okay, the cone just shows you an area with which, based upon the all the forecasts that have been issued by the Hurricane Center over the last 5 years, what the actual error is in, from, at that point. So if I'm looking at, like, say, a 60-hour forecast point, it's giving me what the average error was from where the center actually ended up. And then it's doing it over a 5-year period. So we may have some larger time steps in there. Maybe some years the forecast wasn't as good, maybe other years was better. But all it's telling me is that within this circle, okay, that time step, that 2 out of 3 times the center of the storm will be within that cone. Just 2/3. That means 1/3 of the time it's going to be, from a probability standpoint, going to be outside that cone. So if this was a forecast from Hurricane Florence, this is 5 days out from making landfall in North Carolina. As a planner, if I'm down in Georgia, am I out of the woods? No, I'm not out of the woods, because 1 in 3 chance that it's going to be outside this area and be potentially impacting me with the center, but the impacts may be much larger. So the system may move in here, but what's the spread of the system? How large is it? The wind impacts, the surge impacts, all those different things are possible well outside the cone. So when we look at this graphic, don't get too fixated on the cone. Remember that the impacts are going to be larger than the cone, especially as we get down to kind of the last 48 hours. Look how small the cone is. I guarantee you the storm here with this system is much larger. So the impacts are going to be outside that cone. So don't get too wrapped up in the cone, other than knowing that's where the center of the cone of the storm is likely to go 2 out of 3 times. The other thing is, when you start looking at the back end of this, kind of the day 3 through 5 period, these are 24-hour time steps as far as where the center is going to go. These systems tend to wobble around a lot. So you may get a system, maybe as it's moving this direction, maybe it wobbles north for a little bit, maybe it comes back south. Maybe as it's making this forecast to make landfall here, maybe it wobbles further south before it makes landfall. So in theory, based upon their forecast point, I could see landfall anywhere in here, because maybe this comes up and then jogs back that direction. I don't know what that in-between movement is. So I can't just connect the dots here and say, oh, that's where the storm's going. So again, don't get too fixated on the actual cone. Think about the impacts that could be there, the amounts. All right, so if we're looking, let me jump ahead here. I'm going to take a look, a couple of the other things that come down tell me I can't see storm surge warnings. Those aren't included. And any of the inland watches and warnings aren't included either. So this kind of shows you kind of how the cones changed. So you can see we're getting better and better. So from 2003 to 2021, you've had quite a bit of difference as far as where the track goes. So in 2003, if we had a system moving toward Key West, your error could be almost all the way down to Mexico or almost all the way up to Savannah, Georgia. Now we've gotten to the point, if you had that same storm, we're barely, the error cone would barely be into Cuba or maybe up to Melbourne in that area. So we're getting a lot better. The forecast has gotten a lot better. We're doing a lot, so the error is a lot less. So you have a little bit more confidence in the track, but every system is a little bit different. Some tracks are very, very consistent. The Hurricane Center really is able to lock in on, the models lock in. Other times it's, especially the weaker ones, it can be all over the place. It can be very difficult, very challenging. So, just think about that when we're dealing with the error. But overall, I think we're getting a lot better as far as the actual forecast goes. Time of arrival graphics, these are all part of the NHC page and package. I'll show you where they are in a minute on our web page. But these can be good from a preparedness standpoint. You have 2 types of graphics. You have the earliest reasonable graphic, which the earliest reasonable is kind of the, only 10% of the time would the storm get there earlier. So what they do with this is they take the general forecast and they will run it through the models. And they'll run it about 1,000 iterations through the models. And then based upon all the different scenarios, they come up with these time frames. And so let me jump back here. So if it's the most likely, that's kind of the 50-50 split. So you can use these as a kind of a timing thing of when I need to get my preparations done, things of that nature, so that I'm prepared if one of these systems comes in. So that's kind of how you can use the 2 graphics together. The earliest reasonable is, hey, if I want to make sure I'm in good shape, get it done by then, but kind of the last ditch time is that most likely time. I need to have it definitely completed by that point in time. And this is when tropical storm force winds would make landfall. Storm surge watch and warning. There's a lot of things here when we're dealing with the warning. We're within 36 hours, and we're thinking, yeah, we're going to have some issues with storm surge. Generally, we're looking at 3 feet of above ground level water at that point. A watch, possibility. Okay, at that point, we're like, you need to be prepared. You need to be thinking about what your plan's going to be. Warning, we're going to be activating that plan, whether it's evacuations, whether it's moving to higher ground, things of that nature. All right, so this is kind of what that graphic would look like. This was one that this was from Dorian in 2019. So it highlights the area where, as a forecaster, we really think the risk is. This isn't computer generated. This is all what the forecaster thinks as far as the guidance that we're looking at of where we think we need. And it's done in consultation between the Hurricane Center, the Storm Surge Unit Specialists, and the WFOs. Again, watches are within 48 hours. Warnings would be within 36. Potential storm surge flood map. This map is computer generated. It's generated based upon all the simulations that the storm surge unit is running. And this is a 10% exceedance. So 90% of the time, or only 10% of the time, would we expect to see values higher than what are shown here. But this kind of gives you a graphical indication as far as where water might go and what the water depth might be. So again, it can be a good planning tool, but remember, 90% of the time it's going to be less than this value. So, you can't take this graphic as this is how much water I'm going to get. It's more of, hey, if I get kind of the reasonable worst case scenario, this is what I would expect at my location. So again, it's a good planning tool to help you figure out, but it's not the end all be all because it's all computer generated. So the other graphic to look at, this is one that's being produced now by the Hurricane Center, and this actually is taking into account what their forecast is and then color coding it. So let's say we're in this area that's 15 to 20 here, kind of between the Rockefeller Wildlife Refuge and Johnson Bayou. You're talking about 15 to 20 feet of surge. Well, not every place in that area is going to see 15 to 20, but the maximum value possible in that area is 15 to 20. So that's what those numbers mean. It's the maximum value that could be possible. And we saw that when we dealt, I know when LAR came ashore, there aren't a lot of gauges down on the Louisiana coast. So the one gauge that was there in Lake Charles got up to about 9 feet. People were like, oh, you didn't see as much as you were expected. Actually, when they went back and actually did high water marking and stuff, when they were finally able to get into some of the most damaged areas, they actually found that 15 to 20 foot storm surge based upon watermarks, high watermarks and stuff that were left. So again, not every place in that area, but some place in that area is expected to see that 15 to 20 feet. So again, it's a good planning tool to help you plan for what is the worst that you could possibly expect. All right, on our webpage, you can go on the local webpage. There's a little tropical icon on the main page that will take you to the tropical page for our office. So there's a lot of different tabs on here. If there's an active storm, there'd be another tab that pops up in here that says active storms. You could click on it. The first image you would go to would be to the cone graphic, and then you could see all the other graphics that I was showing you earlier. So all those are available there on this page. The HTI graphics, if you went on the threats and impacts tab, you would come to these HTI graphics. And these HTI graphics really give you, based upon the weather type, whether it be wind, storm surge, flooding, rain, it gives you what the potential impact would be in your area. So in this case, you can see the purple area down here in Florida, and this was with Michael, potential for winds greater than 110 miles an hour and what type of impact you could expect. So all those things are available. And typically those come in about 48 hours from when the storm would make landfall. So this is an example of all those graphics, whether it be the wind threat, the coastal surge, the flooding rain threat, or even the tornado threat. So each one of these has the values, and you can click on it and see what the impacts are. And again, these are done at the Weather Service office level. So at our office, we would be producing the ones for the Wakefield office. And we collaborate with our neighbors to try to make sure that we're all consistent and have a good picture so that, we're, giving the same message, whether it be, in the western part of the state, the northern part of the state, or down here, depending upon where the storm is going to be going. Okay, so that's under the threats and impacts tag, so you can find that there. We're going to scroll through these guys. So those are all those things, and you can click on each one to get what the potential impact would be. All right, so again, the reasonable and the most likely arrival times, again, those graphics are available on our page. The flash flood guidance. Okay, this is a graph that you have actually, that's actually a composite of the next 3 days. So this forecast is done through day 1, day 2, and day 3. So it tells us where we think the flood threat would be located. And on the next image, I'm going to show you kind of, these are what the values mean. So if we're talking marginal, we're talking isolated flash flooding possible. Slight would be a little bit more likely, and it ramps up. So we get the numerous and eventually widespread. So when New York City and then we're dealing with Ida last year, they were up in the moderate and the high, and that had been the first time in 10 years that a high flash flood risk had been issued for that part of the country. So that gives you an idea of just kind of what we were dealing with last year in Ida and the threat that's associated with it. Let me stress this. Make sure you're getting your information from trusted sources, whether it be from emergency management, web pages, whether it be from weather service pages. Make sure you're getting it from a trusted source. Too many times we see this kind of thing where you're getting, people put fake images, people putting fake images out there, people hijacking things and putting information in, stuff of that nature. We don't want to do that, okay? We want to make sure that we're getting credible information to make decisions upon. So it's important. Make sure you've got good, solid sources. Unfortunately, we do get a lot of people who think they know more about the weather, who aren't actually part of the process, who start putting stuff out there and can lead to a lot of bad information. So we don't want to do that. Make sure you've got a good source. All right, last thing. This is it. We've reached the end of the line here. We're going to be looking at the outlook for the season. 14 to 21 storms. 14 to 21. That's what we were last year. Okay. So we're looking at 80, or actually a 90% chance of an average to above normal season. So 14 to 21. 14 would be normal. That's average. 21 would be on the high end. 6 to 10 hurricanes, and then 3 to 6 major hurricanes. Now, let me say this. The one thing that you can't gather from this information is it going to impact my area? No one can tell you that. We do a pretty good job of being able to hit usually the target zone of where the number of named storms would be, but predicting landfall, can't do that. So don't try to glean landfall from this. Just know at this point we're looking for a more active than normal season, 14 being the kind of the normal, 7 hurricanes, kind of 6, 7 hurricanes being normal. So we're just on the higher end there as well. So expect an active season, but it can't tell us whether we would have major impacts in Virginia or whether a lot of these storms end up staying off the coast and out to sea. Can't tell that at this point. But right now, it's important just to kind of be planning for the fact that we will have an above normal season. And sometimes it only takes 1 year or one storm to make a season. If you think back, and I'm going to go back to Hurricane Andrew in 1992, it was actually a very quiet year. I think there were only 8 or 9 storms that year. So we actually were below normal as far as the number of storms. But that one storm was so devastating, it made the entire season. So, just because, we have an active season doesn't mean the impacts will be greater. But you got to prepare for it, because obviously with the more number of storms, the more likelihood that we will see at least 1 or 2 that do impact the region. So that's everything I have. Matthew, I can take any questions that may have come in.
Eric, thanks so much. That was great information, great tools and takeaways for our healthcare partners across the Commonwealth. And at this time, I have no questions in the chat. We'll give it another 30 seconds or so for the listeners to place their questions in the chat box. And then all right, Eric, got one question for you. How can you get records of the timing when watches are declared and when they're closed out or canceled? So I guess the difference between how many times a watch or a warning was issued and when they were no longer in effect. How long do they lapse? I believe is the question.
Yeah, typically speaking, your watch will be issued about 48 hours before the expected landfall. That's generally the time frame. If the Hurricane Center is confident on their track, sometimes they may move it up a little bit. and go maybe a little bit earlier, because we know from a planning perspective, the more lead time, the better. Your warnings are going to go up about 36 hours in advance. Those are the general timeframes, and typically we will hold on to the warnings until we've seen the tropical storm force winds have abated. So that's usually the kind of the time frame as far as that goes. And the way the process works, the Hurricane Center puts the warnings up along the coast, and then the local office then puts the warnings inland. So so we're working together on that. It's a consultative decision, between the Hurricane Center and the local office, as far as kind of where we're going to put the warnings up, where we're putting the watches up, whether it's tropical storm or whether it's hurricane. So those decisions are kind of made in collaboration. But again, usually you can expect somewhere in the 48 to kind of 60-hour time frame would really be the earliest you would see a watch, and then the warnings would start around 36 hours. Now, the hurricane warnings will give you the wireless emergency alert. That was one thing I didn't really touch on. So anybody that's in those areas where we put the hurricane warning up, it's going to alert on their phone. So just like you would have, like with a, if we issue a tornado warning, it pops up on your phone to tell you that. If we issue a hurricane warning, when we issue the first issuance of that warning, it's going to pop up on your phone as well. So, and knowing that sometimes based upon the cycle, because when we're working with the Hurricane Center, the Hurricane Center is working in 6-hour cycles. So they're working generally from 11 a.m., 5 p.m., 11 p.m., 5 a.m. are generally, in daylight time. Those are the time periods when new packages come out. So each time a new package comes out, that may be when we expand products. So usually a lot of times we will try, if we're going to be putting watches up or warnings up, we try our best to do it either on the 11 a.m. or the 5 p.m. advisory update, because we know based upon, people's livelihoods, getting a WE alert for a hurricane warning at 5 a.m. in the morning, not everybody's really happy about getting at that point. I think they'd rather finish their night's sleep and get it a little bit later in the morning, things of that nature. So, we're cognizant of that, but generally speaking, we're working in those four, four time steps: 11 a.m., 5 p.m., 11 p.m., 5 a.m. when we issue things and we issue those products. But 48 hours out for the watch, 36 hours for the warning.
Thank you, Eric. One last question. I know you and I spoke. This was a lesson learned, or a token information for me. Does the National Weather Service have an app, or do you use? Can you recommend the National Weather Service mobile webpage?
Yeah, we don't really have an app, but that mobile web page is really, really good, and it's something that everybody can use. So that would be the direction that I would go. And I think there's actually on our main web page, on our briefing page, there's actually a link to be able to go to that to sign up for that.
Excellent. Thank you, Eric. This is Matthew Marion. On behalf of the Virginia Hospital and Healthcare Association, I do want to thank you for taking the time this afternoon to brief all of our members and stakeholders across the Commonwealth. Thank you again. The recording, as a reminder, will be sent out this afternoon, probably within the hour or two, to all registrants for this webinar. And again, please take advantage of all of the great resources that are discussed that the National Weather Service offers, as today kicks off the first day of the 2022 hurricane season. Thank you all for attending, and this concludes today's webinar.